What about other worlds? In the distant future, when our descendants look back on the first half of the 21st century, what will they remember us for? Maybe when we took the first steps to answer the question, is there life outside our lone planet? New instruments like NASA's James Webb Space Telescope could bring us closer to that answer. How do we find life in our galaxy? First, we need to identify planets with the potential to host life. We've been working towards this goal for the last 20 years. Now the science of planets around other stars, or exoplanets, has grown from science fiction to reality. Before 1995, we only knew the planets in our own solar system. Now we know of several thousand planets and are likely to discover thousands more. Nearly every star has planets, and at least 1 in 10 has an Earth-sized planet, and some have more than one. Each of the stars in this image might have many planets, but how would we know? Imagine if we were aliens looking at the sun from far away. How would we know Earth was there? Earth is 1 trillion times fainter than the sun and very close to it. Try looking for a firefly next to a big searchlight, and you can understand the problem. Some planets are found by a technique that uses Einstein's theory of general relativity, observing the bending effect of gravity from a hidden planet as it warps the light around its host star. The most common method is to look for an eclipse or transit as a planet passes in front of its host star. This is how the Kepler Observatory found planets, by staring at a large region of the sky and waiting for planets to pass in front of their stars, taking snapshots every second. The Transiting Exoplanet Survey Satellite uses the same technique on our nearest neighbor stars. Another technique observes very small changes in the star's position in the sky, the wobble that occurs when an unseen planet's gravity tugs on its host star. If the planet and star are oriented so that the star is moving toward or away from us, instead of side to side, we can detect the planet as a shift in the star's light. As far as getting pictures of the actual exoplanets themselves, it's possible, but very difficult. The telescope has to block the bright star's light to reveal the faint planet nearby. So now that we've found planets, how do we learn more about them? What are they like? Would we want to go there? The TRAPPIST-1 system has 7 Earth-sized planets, with 3 of them in the habitable zone. But we know very little about their atmospheres. The Hubble Space Telescope can tell us whether these planets have hydrogen-rich atmospheres, like icy gaseous Neptune, or atmospheres more like rocky Earth. To measure the planet's composition and atmosphere, we need to use a technique called spectroscopy. Astronomers use spectroscopy to sort light into its very specific components, since different chemicals and dust particles give off different telltale fingerprints. The Webb telescope has 4 spectrographs, which will be trained on a few lucky exoplanets. We'll learn about the atmospheres of these planets by seeing their fingerprints as a shadow against their bright host star, in a similar way to the transit technique. Life changed the atmosphere of our Earth over time, increasing the oxygen and decreasing the methane. By taking a virtual sample of the atmosphere of these exoplanets, we can look for evidence of carbon dioxide, water vapor, and methane, signs of life as we know it. With Webb, we can scan for evidence of biological processes trillions of miles from Earth. So, are we alone? Webb and future missions may finally help us answer this question.